All right, good morning. Happy St. Patrick's Day. Make sure you wear some green today. You don't want to get pinched. So we're in that long day today where we go to all of our classes. You might have noticed this morning, I added something to that CAS practice. You don't need to worry if you're a 12th grader, you do not need to worry about that. We have 3 11th graders in this class, and the 11th graders, what I posted was like a pre-session prior to taking the CASP in April. So it's not exactly what we're going to do, but it's close. The test is really, it's simple to get in the test, but if you want to look at that to make sure you have everything you need, 11th graders, I put that in the bottom of the assignment there, that slide presentation. I am submitting grades on Friday for 3rd quarter. These grades do not go on the transcript, but it's kind of like a wake-up call. And just know that if you're in the 50%, you can totally pass the class with a C or better. You don't want to give up. There's always hope. I'm the teacher, so we can do anything you want as far as enhancing your grade. We just need to work it out. So anyhow, I never want students to lose hope with the grade, because why take the class? Why stay in the class if there's no hope of you passing? So there's always hope. So I guess it's good news and bad news. I want to take an exam on Friday. I did think about it, and we are done. And what I don't want to do is I don't want to wait for 2 weeks, and because it will not be good. So we are done with 3334, and I do want to take that exam 3334 on Friday. So what we're going to do today is a very thorough review of 3.4, and I'm not sure what we're going to do tomorrow. So at least today, you should be able to solve an exponential equation, and you should be able to solve a logarithmic equation. All right, does anybody want to ask me any questions before we get started? All right, so today I'm going to enable the chat. So if you're wondering, why doesn't she enable the chat? Everybody else does. I actually like the chat, but when I'm trying to teach, I feel like I need another person to field the questions in the chat. So if you're wondering why I turned it off, it's just because I can't address the questions and comments. So today I'm turning it on though, because in the chat, you're gonna tell me, yes, I'm done, with the problem. And we're gonna go through a very structured review with me. All right, so I'll let you know how that's gonna work. But why don't you open up your books to page 488 and get some paper? Page 488 and get some paper. Anybody want to ask me any questions about anything right this second? All right. So what we're going to do first on page 488 is we're going to solve exponential equations. So, and then we will solve logarithmic equations. But right now we're solving exponential equations. So let me put the problem up. This is problem number 2. And remember, or you should know that if I give you 100 problems, it's not going to be the first 1 or 2 problems. I mean, there's a mixture of different problems in one section, right? So you can't just do the first 3 or 4 problems. If I give you 100 problems, there's mixtures of problems in the section. So let's take a look at number 2 first. All right, now, when you're solving an exponential equation, you want to get the bases to be the same. That's the whole goal. Because if you get the bases to be the same, you can eliminate the bases and get that variable down from there. All right? Okay, so I'm going to enable the chat. What I would like you to do is I would like you to get 81 to look like a 3 using powers. And I want you to solve for x. In the chat, you're going to put a C for complete when you're done. Okay, so when you're done solving this, put a C in the chat for complete. and we'll take a look at it together. Put a C in the chat when you're done. All right, let's take a look at what we have here. I'm not going to wait for everyone to finish, so I'm going to get a majority of students and we'll go on. So anyhow, we have 3 to the x, and we're going to write 81 is 3 to what power, class?
The 4.
So guess what? Remember that property I gave you that says, and I would put this on a piece of paper, that property. When you have the bases the same, you can get rid of them. So isn't this just x equals 4? Yes, no?
Yes.
Yes. All right, let's try another problem. Number 6. Number 6 is 3 to the 2x plus 1 is equal to 27. So you want to try to get the base to be the same. So I think you can make 27 look like a 3 using powers. This time in the chat, you're going to put an H when you're done. So when you're done, put an H. Okay, here we go. This side is okay. How did you write 27, class?
3 to the 3rd power.
All right, we got the bases to be the same. What do we do now?
You get rid of the base.
Get the variable down, right? Get the variable down. So we get 2x plus 1 is equal to 3, and that's linear. So we just solve for x. Subtract 1 would be 2. Divide by 2, x equals 1. Put yes in the chat if you got it right. Put yes in the chat if you got it right. Good job, guys. Good job. All right, let's try another one. We're on a roll. Number 11. 9x equals 27. Now, 9 times 3 is 27, but we don't care about that. We're trying to get bases to powers. And you can't get 27 to look like 9 to a power. You can't make 9 to something look like a power. But there is a number that you can use to get something to a power to get 9 and the same thing to a power to get 27. So let's see if you can get it. And when you do it, put an S in the chat when you're done. Put an S in the chat when you're done. You're trying to get the bases to be the same. Come on, you can do this. What number are you guys using? Somebody answer me, please. What number are you using to get the bases to be the same?
3.
Yep. Put an S in the chat when you're done. So this is going to be 3 something to the x power. Three to what power gives 9? 3 to what power gives 27?
2 and 3.
So wouldn't this be 3 to the 2x equals 3 cubed? Yes or no?
Yes.
So what do you get?
2x equals 3.
And when you solve for x, you divide by 2. So what's your answer?
3/2.
3 halves, right? Power to power, you multiply the powers. Can't forget the rules, you guys. Too many rules to remember to forget them. Let's do another one like this, number 9. Number 9 is 32 to the x equals 8. You cannot put 8 to a power. 8 times 4 is 32, but you cannot put 8 to a power to get 32. So you're not going to be able to get the bases to be 32 or 8, but you can get them to be another number. So what other number can you get the bases to be?
4.
Don't answer, just 4 is not going to work. 4 is not going to work. What other number can you get the bases to be to write those as powers? And 4 was an excellent guess, but it's not going to work. It's got to be another number. Remember, you're trying to write the bases to powers, right? So 4 times 4 is 16, times 4 is 64. You're not going to get a 32 that way. But there's another number you can use. And when you're done in the chat, let's try the S again. So put the S in the chat when you're done. All right, let's give everybody a hint. Oh, you all got it? Okay, so here we go. What number did you use for the base of the exponent, guys?
2.
Yep. So 2, you're going to do 2 to some power to the x. 2 to what power?
4.
4 or 5?
5.
5. 2 to what power gives 8?
3.
So you got the base. Okay, so then we have to multiply this. So this would be 2 to the 5x. You multiply the powers equals 2 cubed. So what do you get?
5x equals 3.
5x equal to 3. So what's your answer?
3/5.
3/5. Right? All right, let's try a different type of problem. We're going to the next set, which is problems number 23 on. So let's do number 23. 10 to the x equals 3.91. Well, first of all, if you have a decimal, you know you're going to have to use a calculator. Second of all, you got to get them down from there. And you can't get the bases to be the same. I don't care what you do. You're never going to get that to look like a 10. You're never going to get that to look like a 3.91, really? So we're completely stuck. So when you're completely stuck, do you remember what I said? I said take a natural log to both sides. Remember that? So this would be natural log of 10 to the x equals natural log of 3.91. And so somebody tell me, why did I do that?
You couldn't put them as the same base to the exponent.
We can use the power property. And I would have the logarithmic definition on your paper in front of you. I would have the power property, the quotient property, the product property. So this one is the power property, which means we can bring the x down and multiply. And now can't we solve for x? Can't we divide both sides by natural log of 10? Yes?
Yes.
So put this in the calculator. What is the natural log of 3.91 divided by the natural log of 10? Somebody shout it out when you get it.
.592.
0.59. Good enough. $27. 5x to the 17th. We just did a problem like this. But this one's different. Because we can't make a 5 look like a 17. I don't care what you do. You can't make a 17 look like a 5. That's not going to happen. So what I want you to do is I want you to take a natural log to both sides, use the power property, and put a, what should we put in this time? Put in a C in the chat when you're done. Oh, good. You have 2 people, 3 people? Four people? And by the way, that is not an IN, it's an LN, natural log. So what can you do, class? We're trying to get them down. What can you do now?
Use the product property.
It's the power property. It's the power property. X natural log of 5 is equal to the natural log of 17. Solve for x. Divide both sides by the natural log of 5. X, and you're going to put that in the calculator. What's the natural log of 17 divided by the natural log of 5?
$1.76.
That's correct. So when you cannot get the bases to be the same, take a natural log to both sides and use the power property. Let's try number 35. 35 is the E number. So the 5x minus 3 is equal to, actually minus 2 is equal to 10,476. 10,476. All right, now just like we solve any equation, you want to add 2 to both sides first because you're trying to isolate the variable. After you add 2 to both sides, you're going to do what we did in this problem right here. All right, this time put an H in the chat when you're done. Okay, I'm not sure why we're stuck. Use the power property. Got to put in parentheses though, right? Because you got to distribute. So don't you distribute, isn't this 5x times the natural log of E minus 3 natural log of E, the distributive property? So can't you solve for x? So don't you have 5x natural log of E? Ah. Equals, hold on a second. Natural log. I got a better way. I got a better way to do this. Watch this. Watch what I just noticed when you work with an E number. Check this out. We're not going to use the power property. Watch this. Isn't this log base E of E? So doesn't E automatically come down by the inverse property? Isn't this log base E of E? So isn't this just 5x minus 3 automatically? Yes or no?
Yes.
Can't get my board to dry out. Frustrating. Okay. Log base E of E to that is 5x minus 3. So can't we just add 3 and get 5x is equal to the natural log of 10,478? Now that's inside the logarithm plus 3. And so now can't we just divide by 5? And isn't that going to be our answer? See what I'm saying? Isn't this 5x minus 3? And then to solve for x, we add 3 to both sides, and then we divide both sides by 5. So don't you just put this in the calculator? This thing plus 3, hit enter and divide by 5. What do you get?
Uh, 1.85.
I think it's, can you check it again? I think it's 2.45. Make sure you close this parenthesis. So it's a natural log of parenthesis 10,478 parenthesis plus 3, hit enter and divide by 5.
Wait, Ms. Birch, when you add 3 to both sides, 3 doesn't go into the 10,000?
No,
I don't.
no, because remember what I said about things that are inside the logarithm? You can't touch them. So because he's inside the logarithm, you can't touch him.
Okay.
So this is the number 3. This is the log base e of that. This is not 10,478. It's the natural log of it. So this thing cannot be touched. Can't touch things inside the logarithm unless you're using a property. Like for example, let's say you had the natural log of 7 plus 8. That 8 is not in the log. The only thing that's in the log is that 7. So if you put this in the calculator, you would have to put the natural log of 7, hit enter, and then add 8. That's not part of the logarithm. It would be part of the logarithm if it was written like this. That's part of the logarithm. But just to be like that, it's not part of the log. It's not inside the logarithm. What'd you guys get? Did you guys get 2.45?
Yeah, I got that answer.
All right, do you want to do one more of these or no? So remember, when you have the E number, when you take a natural log to both sides, it's going to go away because it's going to be log base E of E to the power is the power. Right?
Yes.
So it saves a lot of work. So just remember, when you have an E number, the natural log of E is log base E of E. It goes away. Remember, the base of the logarithm and the base of the exponent cancel by the inverse property. Remember? Log base B of B to the X equals X. Remember that? Let's try another one of these. 37. 7 to the X plus 2 is equal to 410. Okay, you are never going to make the 410 look like a 7, and the 7, you're not going to be able to do it. So you're going to have to take the natural log to both sides. Actually, this isn't one of those problems, huh? It's okay, let's do it anyway. Let's do it anyway. You're going to have to take a natural log to both sides. When you're done, put an H in the chat. So log base E of 7 doesn't do anything. You're going to have to use the power property and get them down. Use the power property and get them down. and solve for x. Put an H in the chat when you're done. Gonna have to distribute, right? Distribute. Solve for x. Distribute, solve for x. Can't put those together, right? One has a 410 in the log, one has a 7. Can't put them together. It's going to be natural log of 410 minus 2 natural log of 7. Put an H in the chat when you get the answer. Okay, what'd you guys get?
I got 3.0.
I think it should be 1.09. Natural log of 410, close the parenthesis, minus 2 times natural log of 7, close the parenthesis, hit enter, and divide by natural log of 7, close the parenthesis, 1.09. So you have to, the calculator's going to force parentheses, so you have to close them. And then you have to hit enter and divide by natural log of 7 and close the parentheses. If you don't close the parentheses, you're going to be getting wrong answers. So there has to be an even set of parentheses. Can you guys put an H in the chat if you're able to get the answer? This is the answer. Are you able to get the answer on the calculator? All right, I only have 4 people that have said anything in the chat. So what is it that you're confused about? Just like terms, these cancel out because you have a natural log of 7 and a natural log of 7. If the logs don't match up, like this is natural log of 410, natural log of 7, you can't put them together. You can't touch, you don't have like logarithms. Can't put them together. So the only way to do this right here is to put it in the calculator correctly using parentheses correctly. All right, let's move on to problem number 50. Okay, now we're switching gears and we're solving logarithmic equations. So number 50 is log base 5 of x equals 3. And in the notes the other day, I told you that if you have one log, use the definition of a logarithm and write it in exponential form. So when you see this, the first thing that comes to your mind, like, I can't do it. I can't do it. I don't know what to do. And as soon as you say, I don't know what to do, you're thinking about writing this logarithm in exponential form. All right, so this time in the chat, when you're done, you're going to put an S and you're going to write this in exponential form and solve for x. So we're trying to get the x out of the logarithm. He's stuck in there. All right, in the chat, put an S when you're done. So on your cheat sheet, you should have the definition of a logarithm and what its corresponding exponential form looks like. All you're doing is writing this in exponential form. How do you write it in exponential form? It's taking too long. How do you write this in exponential form? Take the base of the logarithm as the base of the exponent to what power? To the third power equals x. X equals 125. Right? Right. Let's try another problem. Let's try 53. Let's see, 54. Log base 5 of x minus 7. Equals 2. Oh, by the way, you got to be careful. You got to make sure that your answer does not make the logarithm negative. So this is a good answer because it does not make the logarithm negative. So here's another problem. You're trying to get rid of the word log by writing it in exponential form. So write this in exponential form and solve for x. And please put an S in the chat when you're done. Thank you. We have 3 people. Let's get at least 5, please. 4. There we go. All right. So writing this in exponential form would be 5 squared equals x minus 7. So this is 25 equals x minus 7. This is linear. So solve for x. So add 7, it goes away. Add 7 is what? 32? Yes?
Yes.
So can you have a 32 there?
Yeah.
Yes, because it does not make the logarithm negative. Now, if you had like a -8, can't have a -8 because it makes the logarithm negative. You can have a negative answer, but you can't have an answer that makes the logarithm negative. Let's try another one. So whenever you have a single logarithm, this is what you're going to do. Let's try 62 6 times the natural log of 2x, so that's stuck in the logarithm, equals 30. How do we get the x out of the logarithm? Well, first of all, shouldn't you simplify this and isolate the logarithm, isolate the variable? So shouldn't you divide everything by 6 first? Then you're going to write it in exponential form. And hopefully you know what the base of a natural log is. The base of a natural log is what, class?
E.
E. All right, when you're done this time, you're going to put a C in the chat. Put a C in the chat when you're done. All right, we got 2 people. Let's try to get 3 or 4. Okay, we got 3. 1 more. One more. Okay, good. How do you write this in exponential form, guys? What's the base of a logarithm?
E.
E to the 5th equals 2x. Solve for x. X equals e to the 5th over 2. And that's a good answer. If they want you to approximate it, go ahead and approximate it. What would it be? What's e to the 5th divided by 2?
74.2.
74.2. So I don't know what they want. This is an exact answer. This is an approximation. You should know how to do both. All right, let's go to another type of problem. Let's go to number 68. Last one for today. So 68 is log base 6 of x plus 5. Plus log base 6 of x. So remember the condensing property? Remember the condensing property? So can't we condense this? And then write it in exponential form? So for the sake of time, since class is over, oh, we got some time. No, 11:05. Is class over, guys? Class is over, right? 11:05?
Yeah.
All right, listen. So we went over these things today. You should be able to do these problems. So make sure you study and do the problems tonight. If you have questions, make sure you're ready to ask me tomorrow. And I'm not sure what we're going to do tomorrow, but on Friday, we're going to have an exam on 3.3 and 3.4 at 8 o'clock. All right. All right, you guys have a good day.